Hey, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so we are in part 2 or lecture 2 of 5 for topic of 5 vectors in our syllabus, and we're going to concentrate on looking at the point of the scalar product. Something wrong happened with the pen here. It did not detect what we call this board. Never mind. Okay, for scalar product. Okay, so we're going to find the scalar product, use the properties, and find the angle between two vectors. Okay, given vectors of A, as you see here, and also B, and theta is the angle between the vectors, that the scalar product of A and B is defined as, okay, as you see in the screen here now, okay, multiplication of the magnitude of I and I plus with J and J plus with K multiplied with K, A3 times B3, A2 times B2, A1 times B1. Okay, so A would be equal to modulus of A times modulus of B cos theta. Okay, so when A vectors of A and B begin from the same point here, so from O to A, then we put, let's say we go from O to A, we put as a vectors of A, and O to B as a vector of B, and between these two vectors there's an angle we denote as a theta here. Okay, so then theta equal to cos of A dot B equal to modulus of A and modulus of B. It will be like this. Vectors of A dot vectors of B equal to modulus of A and modulus of B. Okay, between these two, cos theta. So then cos theta equal to A dot B divided by modulus of A multiplied with modulus of B. So then theta equal to, as you see the screen here now, equal to cos of A dot B divided by distance of A and distance of B, modulus of A, modulus of B here. Okay, the first example, given that A and B on the screen here now, find the vectors, find the what we call scalar product of A dot B, which I think I'm going to just list down here now. Okay, A dot B equal to multiplication of magnitude of I with I, 2 times negative 1, 2 times negative 1, plus with 3 times 2, 3 times 2, and plus with negative 4 times negative 1. Okay, 2 times negative 1 is negative 2, 3 times 2 equal to 6, negative 4 times negative 1 equal to positive 4. 6 plus 4 equal to 10, 6 plus 4 equal to 10, minus 2 equal to 8. Okay, and then find the angle between the vectors. As we know that angle of theta equal to cos of vectors of A dot B divided by modulus of A and modulus of B here. So meaning we need to find out these two first. Okay, we need to find out these two first before we can find out the recall the angle of this. So then modulus of A equal to square root of 2 square plus 3 square plus negative 4 square. Okay, 2 square equal to 4 plus 3 square equal to 9. 4 plus 9 is 13 and plus 16. Negative 4 square is 16. And this one gives you square root of 29. Okay, and modulus of B. Okay, so for this one here now, negative 1 to negative 1. So negative 1 square plus 2 square plus negative 1 square. 1 square is 1, 1 square is 1, 1 plus 1 equal to 2, 2 square is 4, then give you square root of 6. Okay, so then the theta equal to arc cos of, okay, A dot B, the vectors of A, scalar product of A dot B equal to A, divided by square root of 29 and square root of 6 equal to, okay, let's find an answer together here now. Press the button of shift and cos. So you see here now, it gives you arc cos. Okay, and then arrange, we call the formula of this, A divided by square root of 29 and square root of 6. There you go. Okay. Then press the equal button here. Okay, you see here now. It gives us 52.66 degree. 52.66 degree. There you go. So this is the angle between the vectors of A and B according to the question of example 1. Okay. Algebraic properties of a scalar product, which I think that you may refer to recorded lecture notes given to you. Okay. And also here. Okay, then. Okay, so look at this one here now. Scalar product of A dot B equal to the modulus of A, modulus of B, if and only if A is parallel to B in the same direction, meaning this is a vectors of A and this is a vector of B. Parallel, yes, is a parallel here, meaning that at any point these two vectors won't meet at any point. Okay, from the beginning until the end, it won't meet. We call the vectors. It won't intersect or meet between vectors of A and B. And parallel. Beside that, we need to consider is the same direction, meaning direction of this here and also here. And scalar product of A dot B equal to negative modulus of A and modulus of B. Okay, scalar product here. A is parallel to B. Okay, these are vectors of A and these are vector of B. But then the second, we call the things that we need to consider here for this case where A and B in the opposite direction. So first one here and B, let's say here. Okay, the magnitude are equal, is a parallel, but then its opposite direction. Okay, A dot B equal to 0 if A is perpendicular to B. Okay, vectors of A and vectors of B. Perpendicular means that there is an angle the form between the vectors of A and B, which is 90 degree. Okay, A dot B equal to 0. A dot B equal to modulus of A multiplied with modulus of B cos 90 degree, cos 90 degree, okay, plus cos 90 degree. If you sketch the graph of cos sine cos theta, it begins here from 1, and this is pi over 2, where pi over 2 considered as 90 degree, and the value of cos 90 equal to 0. So this is 0. 0 times these two, and of course it's going to give you 0. Okay, now if vectors of A and B stated there are perpendicular, find the values of alpha. Okay, so the keyword for this example, which is vectors of A and B are perpendicular, meaning that the vectors of A and B, alpha and beta, form give us the angle between these two vectors of what we call a 90 degree. Okay, and then it is A dot B equal to 0. So then let's take a look at this one here now. Okay, so vectors of A dot B equal to, okay, now look at this one here now. Vectors of A and vector scalar product of A and B here. Just imagine there is we multiplied the magnitude of I with an I. So 2 times alpha equal to 2 alpha. Alpha times alpha equal to alpha squared. Negative 1 times 3 equal to negative 3, and it is equal to 0. Okay, rearrange of this in the form of alpha squared plus 2 alpha minus 3 equal to 0. This in the form of quadratic equation. So then, factorize this. Then you get alpha and alpha. So product of root negative 3, so it's between 1 and 3, and the difference is positive 2, so which I think that it is plus 3 and minus 1. Alpha times alpha, alpha square, alpha times 3, 3 alpha minus 1 alpha equal to 2, and then 1 times 3 equal to negative 3, which I think that this one here. Okay. Alpha minus 1 and alpha minus 3. So then the value of alpha equal to negative 3 or 1. Okay. Or alpha equal to 1. There you go. Determine which pairs of vectors are parallel. Okay, now for question A, look at this one here now. Between, let's say, if I, for question of A here, let's say I put this one as a vector of U, and this is V. Okay, also U here and V here. Okay, so between U equal to 1, negative 1, negative 1, 1, negative 1, and negative 1. And vectors of V here, negative 1, 1, and 1. Okay, so you can see here now, 1 with negative, negative 1 with 1, negative 1 with 1, meaning that U vectors of U equal to negative 1 multiplied with the vectors of V. Okay, again, vectors of U, 1, negative 1, negative 1. So, negative 1 multiplied the vector of V, negative 1 times negative 1 equal to 1. Negative 1 times 1 equal to negative 1. Negative 1 times 1 equal to negative 1. So, means that the value of lambda here equal to negative 1. So, we come up with a conclusion that these two vectors for the question of A here, they are parallel. Okay. Okay, the vectors of U and vectors of V parallel here. And what about question of B? Okay, vectors of, okay, question of B here. Okay, U equal to 3, negative 2, and 1. And vectors of V equal to 3, 2, and negative 1. Okay. So between 3 and 3, both are positive 3 and positive 3 means that we say that is the lambda equal to, okay, we compare between this and this, and the lambda equal to 1. Between the magnitude of J and J here, negative 2 and 2, then the lambda is negative 1. And between here also 1 with negative 1. So there are two values of lambda that, which I think that we cannot simply say that these two vectors of the question B here, between these two vectors of U and V, they are parallel because there are two values of lambda. So it's not unique then we come up with a conclusion that the vectors of U is not parallel to the vectors of V. Okay, between these two, be a question of B, vectors of U and vectors of V. And there's also alternative method to prove that for question B here, these two vectors, okay, for this one I labeled as the vectors of U and these are vectors of V. And between these two vectors, they are not parallel. If I can show you using a different method for question B, okay, question B, the vectors just now, U equal to 3i minus 2j plus k, and vectors of V equal to 3i plus 2j minus k. Okay, so the alternative method, here. Okay, let's multiply between these two, U and V, which is equal to 3 times 3 plus with negative 2 times 2 plus with 1 times negative 1. Okay, so 3 times 3 equal to 9, negative 2 times 2 equal to negative 4, plus with 1 times negative 1 equal to minus 1. 9 minus 4 minus 1 equal to 4. 9 minus 4 equal to 5. 5 minus 1 equal to 4. Okay, and modulus of A, square root of 3 square plus negative 2 square plus 1 square. Okay, square root of this one here, 3 square is 9, negative 2 square equal to 4, and 1 square is 1. 9 plus 4, 13 plus 1, 14. And then modulus of B equal to square root of 3 square plus 2 square plus negative 1 square. 3 square is 9, 2 square equal to 4, negative 1 square is 1. And also 9 plus 4 is 13 plus 1 square root of 14. Okay, so then the modulus of A times modulus of B equal to square root of 14 multiplied with square root of 14, which is equal to 14. And then we compare between this class A and B. So we shall take that because we agree that we use the term of U and V. U, V, U, V. Okay, U dot V equal to, which is not equal to plus minus modulus of U and modulus of V, which is 4 is not equal to 40. Okay, so they come up with a conclusion that A is not, U is not parallel to the vectors of V. Okay. Okay, we discussed earlier, and this is all the answers for the alternative method for question of B. Okay, never mind. Okay, so the conclusion that the scalar product or dot product here, okay, so as you see the screen here now, please do recall, begin with exercise to make yourself better to understand the process of finding the answer and solution for this question of scalar product. Okay. I'm not going to explain everything one by one here. Okay, the exercise of this, the angle between A and B, blah blah blah, find the value of lambda. Okay, I'm going to give you the answers of this. The value of lambda, the final answer, lambda equal to -1. Okay, so find it yourself. The angle between vectors of A and B is cos of 1 over square of 84. So find lambda. I gave you answers here. Lambda equal to -1. So try it yourself. Okay. And again, okay, please do give a visit to this YouTube channel of Mr. Rodi Rajab. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.